right, so the questions from the 2009 AB exam, as I corrected here, it's number 3. We classify it as a rate and accumulation problem because we are given a rate and we're going to use it to calculate accumulations. And at this point we should be aware that the integral of a rate function is total accumulation. We started off talking about it as accumulation of area. But Mighty Cable Company manufactures cable that sells for $120 per meter. For a cable of fixed length, the cost of producing a portion of the cable varies with distance from the beginning of the cable. That's rate here, 6 root x. You've read the problem. Part A, find Mighty's profit on the sale of a 25-meter cable. So right away, this is jumping into trying to understand a word, and that word is, what does it mean for profit? What is the meaning of profit? And profit is the difference between how much money you earned and how much money you spent. So this is like saying, I earned $100, but I spent $80, so my profit is $20. Okay, so we have to look at these two things. And they're saying, what is the profit on a sale of 25 meters? Well, how much did I earn selling 25 meters of cable? Well, I sell it at $120, so my earning is going to be $120 times selling 25 meters of cable. Okay, that's what we earned from selling it. Now I need to calculate how much should I spend to make the cable. And this is where the calculus comes in. We're given a rate function of 6 root x. That's the rate per meter to produce the cable. If I integrate the rate function, I will get my total accumulation. And we're going to integrate from 0 to 25 with respect to x. Okay? So this is the expression for how much was spent to manufacture the cable. $120 times 25, I don't know, what is that, 120 times 25? Is this I wonder if this was a calculator active question. I don't know, anybody get the 120 times 25? You're a math student. This value is $3,000. And we need to calculate the spent. This is a antiderivative that we would need to do by hand. 6 goes along for the ride. X to the 1/2. If you antiderive that by hand, x to the 1/2, add 1 to the exponent, divide by the new exponent, 2/3 x to the 3/2, being evaluated from 0 to 25, equals 3,000 subtract, if I plug 25 into this, the square root of 25 is 5. 5 to the 3rd is 125, times 2 is 250, times 6/3 is 500. This equals 2,500. Pretty good profits. If you are unable to do fractional exponents in your head, that's fine. You could rewrite this being numerically equivalent 12/3 times 5 to the 3/2. There you go. That's a numerically equivalent answer. And given the level of difficulty of doing this in the head, I'm going to double check to see if this is actually calculator active. All right. It was calculator active. We'll fix that. Calc active. This part is worth 2 points. You get your first point if you remember to include the integral. And then you get your second point if you have your answer of $2,500. Okay? When in doubt, when you see a problem that looks like a rate and accumulation problem, write down the integral of the rate function. Okay. Moving on to part B. Using correct units, explain the meaning of the integral 25 to 30 of 6 root x dx. Now remember that this is the rate of dollars per meter to produce the cable, and if we integrate the rate, we get our accumulation. So integrating from 30 to 25 represents the difference in cost of producing 30-meter cable versus 25-meter cable. So it's like looking at the quote area under the curve. It's going to be the accumulation from 25 to 30, which would represent the difference between a 25-meter cable and a 30-meter cable. And visually, if you think about the function root x, the square root function is a function that climbs rapidly at first but starts to slow down with how much it's climbing per unit. And it would make sense that from 25 to 30, there's a small jump in a cost difference between 0 and 5. Should be a huge jump between 0 and 5 because you have to like set up the factory, and it's much more expensive to do your first 5 meters than it is to do 5 meters way out towards the end. Using correct units, double check our units, represents the difference in cost in dollars. I should put that in there, of producing 30-meter versus 25-meter cable. This is worth only 1 point. Either you understood the meaning of it or you did not. So you have to include the units, meters, and dollars.
No!
Moving on to part C. Write an expression involving an integral that represents profit of sale. Well, we've already established our relationship with profit. Profit is earned subtract money spent. Okay? So our profit is $120 times K meters. That would represent how much we earned, $120 times the number of meters. And then our spent is the accumulation from 0 to the amount we produced of our rate function. So we had already established this relationship in part A. It's coming back in part C. Our profit. Part C is worth 2 points. You get 1 point for the integral, recognizing that we're integrating from 0 to K to indicate how much we spent. And then your second point comes from, do you have the whole expression correct? Part D, we're looking to maximize profit. So since we already have the expression for profit, I'm just going to rewrite it down here. If we want to maximize a function, what we're going to look for is critical values. The critical values will help us either find local maximums or absolute maximums if we have a closed interval. So to find a critical value, we first need to take the derivative. So the derivative of this expression with respect to K, the derivative of 120K is just 120. And the derivative of the integral is integrand of the top times the derivative of the top minus integrand of the bottom times the derivative of the bottom. Okay, so that's the fundamental theorem of calculus, and this is a K. To find the critical value, we are going to set this expression equal to 0 to establish where a critical value occurs. Being that this is calculator active, you could use the calculator to solve this, but it is a pretty straightforward algebra problem. Add the 6 root K to the right hand side, divide both sides by 6, and then square both sides, and you get your critical value. We should test to make sure that that is a maximum, since we're trying to maximize profit. So put your critical value on a number line and test the values of k prime. So if I stick 1 into k prime, I get a positive answer. If I stick 500 into k prime, I will get a negative answer. This tells me that k transitions from increasing to decreasing. So because that is the only spot, you could say that the profit continues to drop off as the meter gets longer and longer and longer, or the cable gets longer and longer. So max profit of 120 times 400, subtract integral 0 to 400 of 6 root x dx, which if you grab your calculator and type this into your calculator, because it's a calculator active question, we see that the max profit is $16,000 when 400 meters of cable are produced. Are produced? Is produced. This is worth 4 points.
That little sign thing by 16,000.
That's a dollar symbol. Equals $16,000. Yeah. P prime of k equals 0, so if you set the derivative of p equaling 0, that gets you 1 point. If you're able to do the algebra to solve for your critical value, that's your 3rd point. And then the answer, they're asking find the maximum profit. So the answer of $16,000 is your maximum profit. And the justification is the work that we did here with the first derivative test for local extrema. So, I don't know, all of this is your last point.
Thanks for watching, mice, and you gotta hit that bell, like, and subscribe. See you tomorrow.
Nice.